Hey, scholars. So I would love to talk to you about ratios. So if you would, bear with me, and I'm going to share my screen with you. And we're going to start as we normally would with our affirmation and so on. I am an awesome, brilliant child, determined eternally for greatness, helpful, intelligent, joyful, kind, loving, mindful, and naturally outstanding. Phenomenal, questioning, respectable, smart, and talented, unique, and virtuous, wise. Exciting, youthful, and zealous, and then some. Cool. We're going to choose our norm for the day. So I would love for you to do just that. We have a few different options, so I want you to be intentional. Make sure this is something that you can exercise for the entire day. So do you want to be well dressed, well organized, well balanced, well read, well spoken, or well traveled? Every second to think about it. Cool. I'm sure you chose something amazing. And so let's get right into ratios with that well mindset. How can you use ratio and rate to solve real life problems? So by the end of this exercise, I believe that you should be able to recite this with confidence. So I can use ratio and rate reasoning to solve real world and mathematical problems by reasoning about an equation. So let's get started. Math gap. What is a ratio anyway? A ratio, the quantitative relation between two amounts showing the number of times one value contains or is contained within the other. Rate, the speed at which something happens over a particular period of time, the number of times something happens or is done during a particular period of time, an amount that is paid, a price or amount to be paid that is set according to a scale or standard. So we understand here that a rate is how often something happens, and a ratio is the rate compared to something else. So let's look at ratios, right? So we have this concept ratios right here. It's a comparison of two quantities. Like we said, it could be a part to a part to a whole, or whole to a part. It can be written three different ways. You could have in colon or fraction or the word two. So A colon B, A over B, A to B. So right here we have a few shapes and we can create some ratios based off of this. So the comparison of two quantities, this quantity compared to this quantity. We have 1, 2, 3 green circles and 1, 2, 3, 4 blue stars. So let's see how we could interpret or explain what this is in our own language. So we're comparing circles to stars. We have 3 circles to 4 stars. You can write 3 to 4, or 3 colon 4, or 3 over 4, because out of the comparison of 3 green circles to the 4 blue stars. So the stars to total shapes. There are 4 stars to 7 total shapes, and again 4 to 7. And here is a really good explanation, because out of the 7 total shapes, we have 4. So let's look at a real life unit rate. So how can we interpret this real life unit rate? So once you begin to adult, as they say, and purchase things such as laundry detergent, you might want to know what is a good sale or not. How would I know if it's a good sale? I can know it's a good sale based off of the quantity I get, connected to what I pay. So if I pay a certain amount, I would like to use a certain amount. So let's use this example we have here. A Tide is $6.99 for 75 ounces. So let's break this down. Here are the two units we're comparing, the $6.99 to the 75 ounces. So let's look at step one. Write it as a fraction, $6.99 over 75 ounces. Step two, divide the top and the bottom by the denominator. So if our top numerator is $6.99 and it's divided by 75, 75 goes into 699.09 times. 75 goes into 75 once. So we know, based off of this, we can label it that for every 1 ounce, I'll be paying 9 cents. Or I pay 9 cents for every ounce that's in my Tide detergent. Many stores put the unit rate on the price label. Why would they do this? Why do you think? I agree. They might do this so that you know how much you're paying for depending on the brand that you pay for. So here's an example. I'm just going to read the two to you, and then I'll show you an example of some more that you can read and practice on your own. There are 38 cars parked in the parking structure. The parking structure is not full to capacity. There are 13 parking spaces that are empty. What is the ratio of available parking spaces to parked cars? Well, the ratio of available parking spaces, how many available parking spaces are there? Let me use my information. There are 13 parking spaces that are empty. And then it says to park cars. Well, how many parked cars are there? It says that there are 38 parked cars. So the ratio would be 13 available parking spaces to 38 cars parked. How about the second one? There are 17 occupied seats on the bus. 11 seats are empty. What is the ratio of number of occupied seats to empty seats? Start with identifying your information. So I know I have 17 and 11. 17 represents the number of occupied seats on the bus, and 11 represents the seats of empty seats on the bus. Excuse me, the question asked, what is the ratio of number of occupied seats to empty seats? So we see 17 occupied seats to how many empty seats? That's right, 11. So you would write 17:11 or 17 over 11 or 17 to 11. Here are some more for you to look over and practice at your advantage, or rather at your leisure. And I want you to make sure that by the end of this lesson and these practice that you can use ratio and rate reasoning to solve real world and mathematical problems by reasoning about an equation. All right, ladies and gentlemen, thank you so much for your time and attention, and I look forward to doing more ratios with you soon. Have a great one.